I would like to start introducing myself. My name is Wardner Maia. I'm from Brazil, and I am electronic and telecommunications engineer. I've been working as internet service provider since 1995, and in training business since 2002. As MikroTik trainer since 2007. And I am the CTO of MD Brasil, IT and Telecom, and member of the board of directors of LACNIC, the Internet Registry for Latin American and Caribbean. MD Brasil, IT and Telecom is a Brazilian company in São Paulo State, Brazil. We are also MikroTik distributors, and we distribute another brands like gyros, antennas. And we are a MikroTik training center since 2007, and we do consulting services worldwide, mainly in MikroTik, but also in another systems. More details about our company you can find in the URL. So this is my second time in Prague. Is eight participation in months. I have some presentations more related to security, like my friend Tom Smith would like to talk about security. But today I will try a different subject related more to network simulation. And the network simulation we will do with a software called GNS3 with focus in MikroTik HultraOS. And the goals of this presentation is to share our experience in our company using GNS3 for the work and for the trainings, and to foster the use of simulators as a prediction tool and as a learning tool. And I would like to try to present a tutorial on how to install the software, how to use the software, and you see that it's very, very interesting. It's important to mention that other trainers had similar subjects in Indonesia and USA. This simulation tool was subject for presentations using Windows, and one using the Kik emulator and other using VirtualBox. Our presentation is another little bit different approach. We will try to install all the stuff in a Linux, Ubuntu, and we also make available an image for the ones that don't want to install on their machines. It's important to mention that GNS3 is not the only simulator. There are a lot of simulators like Clonic, Score, Marionette, Mininet, and you can find a lot of network simulators. This is an excellent link to see about open source simulators. Of course, each one has advantages for some situations. In our case, we choose GNS3 because it fits better in the kind of networks, IP networks that we work. So, our agenda today will be divided in 5 parts. The first part, we will talk, a general talk, and the motivations to talk about network simulators. And the second part, we will see how to install. We will try to make a tutorial. And then we will create a simple project to see how easy it is to create projects in GNS3. And we'll do also a more complex scenario, a traffic engineering scenario, and see the advantages of using GNS3 as a learning tool. And final considerations, and the links to download all the stuff. So, starting with the motivations, why use network simulators? Of course, we love to work with real routers, but in some cases, it's better to use simulators. One of the reasons that I thought about this presentation was 2 years ago in Zagreb. I did a presentation about BGP filtering, and with this scenario here. And to simulate this scenario, I have to use 5 real routers, and I bring from Brazil with me 5 routers with a lot of cables, with power supplies, and the stuff to join all the power supplies. It's a good bag to transport everything. In 2014, I decided to make a presentation about VPN. VPNs, MPLS VPNs, the security of MPLS VPNs, and the scenario will be with 9 routers. So, to bring 9 routers with the cables, with the power supplies, etc., etc., would be a mess. So I decided to research about the simulator, and we decided to start to work with simulators. So, with simulator, last year, with no physical routers, no cable, no power supply, we can do all the demonstrations without any problem. And on the backstage, after the presentation, several questions were asked about the tool we use to simulate it. So we decided this is a good subject to talk about simulation. We are using a network simulator in 2 areas, as a prediction tool and as a teaching and learning tool. As a prediction tool, the operators can simulate how some scenarios will behave before going to the real world. You can place the scenario, see how things work, and then go to the real world. You can also test software versions. When, for example, MikroTik releases a new version of Router OS, you can test it before going to the real routers. Interoperation with other vendors, because the software, in the same software, we can interact with Cisco, with Juniper, with other brands of Unix, all the stuff we can put in GNS3, and without any equipment, any physical equipment, we can test, we can make our labs. And in consulting services, it's possible to make fast and low-cost proof of concept to the customers. You make the picture of the scenario, you put all the things to work and show to your customer, and then you can show how the things will work. So, a successful case in Brazil was one customer. They hired us to do a job, a consulting service. It was Brazilian Army, one part of Brazilian Army that takes care of the Amazon rainforest, and they have a big network with fiber, with radios. And the network interconnects several units, many in hard-to-reach locations. Some locations you have to go through the forest 3 or 4 days to get to that location. So our challenge was to implement in that network dynamic routing, IPsec encryption, QoS, and other things like firewall, without any interruption. Of course, it's a big work, and before we go to the real network, we place all the stuff working, we simulate the network, and it was very useful to us to decide how steps should be done first, before go into the real implementation. As a teaching or learning tool, the trainers can easily explain protocols, how protocols work, and trainers can explain scenarios without the need of lots of equipments. And students can have the labs on their pockets. They can go to a classroom and they go with the lab in his computer, and he can simulate the things in their houses. In online trainings, you can send the scenarios to the students, and the students can test, can interact with all the scenarios. In our company, we are using, during this year, mainly this year, the last year and this year, we are using a lot of GNS3 for our trainings. For example, we do a BGP class today with a virtual environment simulating the real internet. So the students can connect to sites, to remote sites as they are real, and so they can see how BGP works without the need of the internet, because every time we need the internet in some hotels, it's not possible because the link is very bad, so we cannot depend on the internet, and with a virtual environment you can give such type of classes without any problem. MPLS labs are other kind of labs that there are so many details in the configuration, and is much more productive to show the scenario working before the students manipulate the real routers. We show a scenario, how it works and what we expect of the lab, and then the students go with the physical equipment and make the same. It's very, very useful for teaching. We intend to do this year new labs that in the past was impossible because of the time of the trainings. So, who will benefit with this? Trainers, of course, because they can improve the methods. The students, because they can get more from the trainings. The operators, that they can predict how things will work. And MikroTik community in general can share information using simulators, because it's very common to see in the forums some setups that are not working, and you can send the individual configuration of the routers, but it's much better if you send the scenario. I'm trying this scenario here, is not working. The other side can see and can see how which is wrong. So, the second part will show how to install. This is a tutorial, how to install all the stuff to simulate any type of network. So, we will use these three tools here. GNS3, Quick Emulator, and the Dude. All the stuff installed over Ubuntu GNOME 14.04. GNS3 was originally developed for Cisco routers. It uses a software called Dynamips that emulates Cisco routers. And GNS3 offers also support for virtualization using Quick Emulator and VirtualBox. Quick Emulator is an open source software that can be used as an emulator or as a virtualization system. As an emulator, it can run direct on the PC, and as a virtualization system, it runs in the gas system directly using KVM. And several architectures of hardware can be supported, like MIPS, like ARM, PowerPC, and x86. So, we can simulate RouterOS we using QEMU or using VirtualBox. We did a lot of tests. In our tests, we decided to use QEMU because it's faster, it saves CPU, and our tests, QEMU behave better. At the end of this presentation, we append some tests that we do. So, and the dude will be used only as a front end for the simulations. In fact, the dude will be used to hide some details, to make the scenarios cleaner, to make the facility of accessing directly the routers through the dude. And then we use, it's not mandatory to use the dude, but it's very interesting to use it in the simulations. So, to install all the things, here is step-to-step, and all the commands you go should be as a super user. So I suggest you first to being super user, and then this is a very important suggestion, because to make the process of exchange the projects between different machines is possible if they are in different paths. But if they are the same path, we can share the projects immediately. So I suggest to make a /GNS3 and put all the stuff in that directory. Is that way that we work in our company, and then we can share easily the projects each one is developing. So, in Ubuntu, you have to install all these dependencies, this stuff here and here. You have to install also Python and support for i386. You have to install Dynamips. Dynamips is to emulate Cisco routers, but even if you don't want to emulate Cisco routers, you need to install, because GNS3 needs some dependencies of Dynamips to work. So it's very interesting that you install Dynamips to make GNS3 work correctly. So, to test if the installation was successful, you do this command here, and you receive an output like that. GNS3 will install from the source. The current version, by the time of this writing, is 1.2.3. You can change this if there is a new version. And you install also GNS3 GUI, and IOU is to emulate Cisco routers in Unix systems. So there's a step to create a license if you intend to work also with Cisco routers. You have to follow these steps. All you have to do is to copy and paste this file here and make it executable, and if you type this command here, you receive an output like that, And this is the key that you put in this text file, and the license for Cisco is okay. So, after that, you have to install the QEMU, Kiko emulator, and the dude you have to install, follow the wiki. If you don't have wine, install first wine, and you won't have problems to install the dude. So, to launch GNS3, it will be launched every time as super user. You go here and okay. If all the things were installed that way, you receive this this screen here. So back to the presentation. Okay. The step now is to create the router OS image to GNS3. You have to create an image. Kiko emulator supports a lot of type of images, and the preferred image is this one, called 2, because it is more portable and it saves space, because you will define, for example, this size of file, but it will use only the space needed. The image grows as necessary. So you can also use the raw format. We did some tests and we didn't notice some difference in performance nor in space, of course, is different. So, and then you can install using this command here. So this is the creation, and then now the system is installing the MikroTik. Of course, previously I downloaded the .iso image from MikroTik website, is in the same directory, and you get the screen, a screen like that. If you want to install all this stuff, you can click here. We will install only the minimum for the demonstrations only. You install all the system. Install. Yes, yes. Okay. The system is installing as usual. And now we have sorry. Okay, at this moment we will have a MikroTik installed, and you have to access this, sorry. Okay. Okay, you have the image, the level 0, the image 24 hours for use without license. And then, if you want to put this image in GNS3, it's ready. But every time you create a new router, the time will count and you can lose your project. So it's very interesting to license one image to put first and then put in GNS3 to preserve the projects. So you can license here. In this stage, we don't have contact with my machine with this image, and the only way is to place manually the license, that big amount of characters, but we will see how to access this image without the need of putting that way. So, but it's very interesting that we license the image now. So, if we skip this step, every time we want to go and to open the image, the QEMU image, we can type this command here, and we'll get the same access to the image. So, very important to mention is that the interface Ethernet is the same MAC address. When you put it in GNS3, is the same MAC address, and in GNS3, Ether 0 is Ether 1 of router OS, and Ether 1 of router OS will have every time the same MAC address, so you have to reset the MAC address every time you create a new router to avoid conflicts. So let's see how to insert the image in GNS3 and create a base project. So the steps to insert the image are shown here. You go to tab General, QEMU VMs, and a name of the VM. I usually use only R, and define the amount of memory, and the path to the binary of QEMU, and the number of the adapters. By default, QEMU generates an image with only one adapter, and only one Ethernet, but you probably will five is a good number to work, but you can place any number here. So, and now the path to the image we create. So, I already did all the steps in my computer to gain time, and finally using the dude as a front end to the virtual environment. As you can see, the projects will be a lot of links, and we don't want to show some links like our access to manipulate all the routers. So we use the dude to hide some details and to make things more friendly to use. So now I will show how to create a simple project and interact with them. And in the presentation, there are all the steps, but I will do manually here, because it's very interesting to see. So, we'll start with new project, name test. Okay, and then we will create one router, another router. We'll need also a switch, and we'll need the cloud. So the switch, obviously, is to connect everything. And this device here, the cloud, in fact, is a pseudo device that is, we use it to connect all the stuff with our machine. So I will start configuring. So Linux use a tap interface to connect to this environment. So I add a tap here. And then before I configure the routers, configure the links, I will do a very important thing, that is reset the MAC address and put an IP address in all the routers. So I can start the routers here. If I click here, all the active image will start, and then I can enter and configure the router. Admin, without password. Very important command. Reset MAC address. Ether. Before I will show you the MAC address. So this is the MAC address that is the same for all installations. So we will reset. Ether 1, and we will add an IP address 10.100.01/24, interface Ether 2. That's Ether 1 for router OS, Ether 1 for DNS 3. So this is the first one, and then admin, interface, Ethernet, reset, MAC address, Ether 1, IP address, add address 10.100.02/24, interface Ether 1. Okay? So now I will stop the devices and I will make the links. I click here and then Ether 0 to port 1, Ether 0 to port 2, and the tap to port 8. I will make a link between the two routers here, Ether 1 and Ether 1, and that's it. Our scenario is configured, pre-configured, and then the next step is see how we can interact with this scenario. So we want now to bind our machine to the virtual environment, and then for this we need to have some support for bridging and user mode Linux. And here we have a script. You can copy and paste this script, and all the things will be configured when you run this script. Of course, you have to give execution permissions. So after running the script, you check the bridge and tap configuration, and if you get an output like that, the things are okay. I'm running that script, so the bridge is okay. And the IP address of this my equipment, I configure 10.100.0, and then something is wrong. Something is wrong with my second route, my first router. Admin. Oh, sorry. In fact, the IP address is Ethernet 1. Remove 1, IP address 10.100.0.1/24 interface Ethernet 1. I think I have to stop and start. No, it's okay. So, and now we can launch the dude. And here, I think it's a matter of time, but it's okay. The dude is okay here. And now we can access the router directly from the dude. Much more comfortable. I will get rid of the full IP address, and I will do. Suppose we want to show to a student how to configure a simple BGP section between two routers, okay? I will have address here, 1111/13, ether 2, routing, BGP. This AS is AS 100, for example. Router ID 1111 is peering with router 2, 1112, 200. Okay. And now I will configure the other router. One 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 2/13 3 AS 200, router ID 1112, is peering with R1, 1112, 1, sorry. Remote AS 100. So, the session is established here. This is a simple demonstration. You see how useful is this kind of tool to to teach things like that. So, as a hint, to avoid mistakes, like my mistake in configuring the IP address, as a hint, you can you can have a base project doing all the things necessary, doing the resetting the MAC address, configuring the IP addresses, etc., and you can have, for example, in this machine, in the old version of GNS3, I run 20 routers. I create a base project, and I run 20 routers at the same time without any problem. And then when I want to create a new project, I go to this base project, I save it with another name, and get rid of the routers I don't want, and then it saves time to create new scenarios. There's a problem with this version 1.2.3 here, is because I try to do the same 20 routers at the same time, and I have some problems when the routers are starting all at the same time. So I try to starting manually each one, there's no problem. I can run with the 20 routers, but starting at the same time, I have some problems here. And I tried this configuration here, but it's not working. This configuration is to delay the start of the machines in some amount of time. But unfortunately, it's not working. I reported to the GNS3 guys already. So, to finish our demonstration with GNS3, I would like to show you a real case demonstration, a real case, a real lab that we use in some labs in our trainings, our routing trainings, that is related with traffic engineering. So, at first I will start the project to gain some time. So, is this scenario here? Because of the screen resolution, you won't see you don't see the whole picture, but I will show in the presentation. So, I will start now, and because it takes some time, there are 9 routers. So, while the routers are starting, we will see some background about what we will do here. And this is a class about traffic engineering T tunnel, not using LDP nor BGP, because with MPLS we have 3 ways to distribute the labels: with LDP, with RSVPT, and with BGP. This is using RSVPT. RSVPT is an extension of the protocol RSVP, and it supports reservation of resources along the path, and it supports some limitations. It's a very practical and efficient way to make bandwidth control using RSVP, and we also can define how, which is the route we want to one type of traffic. So, some words about the naming. Here is the customer edge router, the CE router. The ingress router is MPLS router, egress router, and in the middle, the RLSR routers. So, RSVP works that way. The ingress router sent RSVP messages, path messages with the necessary constraints, and the internal routers only propagate the messages, and the egress routers sent back the RSVP messages, reserving the resources for the tunnel and all the routers along the path. So in this example, we will see we are doing some things like OSPF is operational in all the routers. The tunnel is established between ingress and egress router using loopback interfaces because of reasons of redundancy. And the path we define administratively, and the path of the tunnel is not following OSPF routes, but our routes. And when we, for some reason, we lose some path, OSPF can be used as an alternative. Is this scenario that we reproduce here? We have a tunnel between this router and this router, and this router, and OSPF, best OSPF path is through this router, but we, for some reason, we decided that traffic must be through this 3 hops route. So the tunnel is established, and the path, the primary path, is defined here. In case of failure of some router, then this other path will be used. So is this scenario that we are running here. So we'll go to the dude. I think I lost the contact because of that. Have to. It's okay now. Okay, the tap tunnel was outside the bridge when I initialized the software here. So. Now the router are coming up. I will show you. Router 1 configuration is the ingress router. OSPF is a simple setup here. Only networks, only backbone area, a very simple setup. And MPLS doesn't have an LDP enable, and traffic eng has two paths, one primary, and this primary path is where we defined the strict hops that we want the traffic goes through. So we defined with all the IP address, the ingress IP address and the egress IP address of each router, and we define the path, and this configuration will define that the flow goes through that sequence of routers here. And the second path, we use the path established by OSPF. So, let's see. No, I will do something different. I will go from a CE router. So you see that we have 3 hops here to go to 4 hops, in fact, 4 hops to go to the end of the tunnel, okay? And then I will do, I didn't show you the limitations. The limitations are established here. We placed a limit of 10 megabits for this tunnel and a margin of 5% of 10 megabits. So theoretically, these links could be reach 10.5 megabits. Going back to the other router, I will do a bandwidth test now. The tunnel is one direction. If I want the tunnel in the other direction, I have to configure the other router. So I will send the traffic only. And that's it. The traffic here is shaped in 10.4 megabits, 10.5. So now I will simulate if something goes wrong with this router here, for example. I will disable this interface and see what happens with the traffic. The traffic lost some packets here, a little bit, and then the trace route is only one step through the upper router. If the link comes up for some time, it takes some time to recover the original path, to recover the tunnel. It's okay. Now is the original path. So, of course, in this lab, we have a lot of things to do and a lot of things to show. This is a simple example because of the time, but of course, in a real classroom, we can limit and guarantee services by type of service. A lot of things we can improve, and this is possible when we have scenarios like that. To do this in a real classroom with real routers takes a lot of time, and a lot of mistakes can be made. Of course, I'm not defending that we need only to use virtual routers, but it's a tool to help in the teaching skill. So, in this presentation, the configurations are are here, but this scenario, also the image and other things are available for download, and you can install and reproduce this scenario and can see things more interesting than only the limitation. So, as final considerations, we have to mention about the limitations and the issues. Of course, some scenarios that are related to physical capabilities, like wireless, like switching, cannot be reproduced in a virtual environment, so it's a limitation. That presentation in the morning from Leo, of course, cannot be made because it's a presentation with wireless capabilities, etc. Also, problems related to interface negotiations, some problems that in practice we have cannot be reproduced in a virtual environment. About the installation, usually we don't have problems installing on Ubuntu, following that steps, but some students reported some problems because of some type of machine, I don't know exactly, but and to use simulators in a classroom is better if before the training we ask the people to go to the training with all stuff installed and working, because we can lose a lot of time trying to debug some issues on installations. So, and to circumvent such issues, we developed an image in a USB stick and an image using Ubuntu 14.04 long-term support with 32-bit. And this image is available for download, and you can install it in a USB if you don't want to start the routers to install in our system. You can start via USB stick. I prepared some USB sticks here. I have 10. If someone wants, I can give you the image pre-installed. So the reference for this work, they are listed here. Maybe I forgot some reference, and I would like to thank some people here, some persons. My colleague from Brazil who worked with me, Sergio, who helped a lot of debugging the scenarios, the installations. Tom Smith and Patrick Schaub, that we have a commercial cooperation, technical information exchange, and our Czech friend Jaromir for the usual hospitality and for the efforts with the Routed World project. So the presentation and related material can be obtained in this URL. Here we have the ISO image, the USB installer for Windows, the RouterOS image, the tutorial for installation in Windows. This tutorial is in Portuguese, but I think the pictures are enough to make the understand. So, and at the final, I append some slides that are research about the comparison of QEMU and VirtualBox and why we decided to Quick Emulator instead of VirtualBox. And that's it. I thank you for your patience, your attention, and you can, on the backstage, ask me questions. Okay, thank you.